All right, guys, we are looking at day 2 of section 3.1, basic concepts of probability and the fundamental counting principle. Today we're going to talk about classical, empirical, and subjective types of probability. Now, here's the thing. They sound weird and you've not heard, I will grant you that, maybe I'm, all right, I was going to say, goofy. I'm trying to write in white on a white. Yeah, okay. There we go. Subjective you might not have heard of before, but classical is the word that you would have remembered would be theoretical, and empirical is experimental. So you've heard of those two before, you've dealt with those. So we're going to start with classical or theoretical probability. It's when you know the number of outcomes in your sample space and you know the number of outcomes that you want. So like if I'm rolling a 6-sided die, if I want the number 2, that's a simple event. There's only one way to get a number 2. So that probability that I'll roll a number 2 is 1 out of 6. So, and I think actually our first example. Yep. You roll a 6-sided die, find the probability of each event. Okay. And remember, there's only one way to roll a 3 out of 6 possible numbers. So 1/6, and that would be 0.16 repeating, I hope. Because remember, I think this is actually later in our notes. Our probability, we usually, you can write it as a fraction, you can write it as a decimal, and you can write it as a percentage. Usually it's the first two that are the best way to write it. I think I stick to mainly fractions when I'm doing this. Your My Math Lab might want it in decimals, but you know how to do that, just 1 divided by 6. All right, so then the second one, when we're looking at this, an even number. Well, even numbers are 2, 4, and 6. So we have 3 total even numbers out of 6 total numbers. So your actual probability is 1/2 or 0.5. And then for event C, we want to know if we can roll a number that is less than 5. So 1 is less than 5, 2, 3, 4, and I almost included 5. So there are 4 numbers that are less than 5. So it's 4 out of 6 or 2/3 or 0.67%. 0.67, which is 67%. Okay. So that, you've seen that so many times, so I don't think you'll have any problems with that. Okay. Oopsies, press the wrong button. Okay, the next thing we got is empirical. Remember, this one would be experimental, right, is what you are used to calling it. But the reason it's actually called empirical and not just experimental, or actually like empirical or statistical, is because it doesn't have to be just based off of actual experiments. Like you don't have to just roll a die 100 times. You can actually do things. It's basically based on any observations from any type of experiment, which could include a survey or anything like that. So that's why they why it's technically called empirical. But again, it's just the actual number of times you rolled something over the total number of times you rolled the die. Like if I'm rolling the die 100 times, my denominator would be 100, and let's say I got a 2 37 of those times. That's my probability of rolling a 2, like the experimental probability would be 37 out of 100. Okay, there we go. I thought I had pressed the button. I didn't. A company is conducting an online survey of randomly selected U.S. adults to determine how they read books during the past year, if at all. So far, 1,490 adults have been surveyed. So that's actually my total number that have been surveyed. That's going to be my denominator. The pie chart shows the results. Note that digital books include ebooks as well as audiobooks. All right. What is the probability that the next adult surveyed read only print books during the last year? So in our pie chart, we got 578 people out of the 1,490 who read print books. And so the probability that we're going to, the next person, when we survey the person 1,491, the probability that that person will have read only print books is actually 289 out of 745, which is 0.3879. Okay. What is the probability that the next adult surveyed read only digital books during the last year? So again, we have that denominator of 1490 because we've surveyed 1,490 people. And then digital books for us, I'm going to switch to another color. 90, oops, sorry. Thought it was the pen, but it was the highlighter. Read 90, okay, so 91 people did that. And if we get it as a decimal, 0.0611. Okay. All right, let's take a look at, I think we have example 7. A company is conducting a phone survey of randomly selected individuals. Oopsies. There we go. Okay. To determine the ages of social networking site users. So far, 975 social networking site users have been surveyed. So that's going to be our denominator. The frequency distribution shows the results. So again, here's the sum right here. Remember that weird looking E is for sum. It's actually called sigma. And that's 975 people. What's the probability the next user surveyed is 23 to 35 years old? So 23 to 35 years old. Here's our 23 to 35. And again, I thought I had my pen. I did not. So we had, of the 975 that we surveyed, 312 out of the 975 were 23 to 35 years old. So that means the next person surveyed, there is a 0.32 or a 32% chance, I should say, a probability of 0.32, so a 32% chance that that next person will be in that age range. Let me shrink a little bit because I gotta move this up a bit. Okay. Find the probability the next user surveyed is 36 to 49 years old. So again, you're just looking at the table. 36 to 49-year-olds, there were 254 out of the 975 that were surveyed. So that there is a probability of 0.26 or roughly a 26% chance that the next person we survey will indeed be 36 to 49 years old. All right, so then down here we got the law of large numbers. As an experiment is repeated over and over, the empirical probability of an event approaches the theoretical probability of the event. So here's the thing, like we had said, there's a 1 out of 6 chance that you're going to roll a 2. If you only tried that experiment 10 times, the experimental probability that you rolled a 2 might be like, you might actually get like 4 out of 10 were 2s, or it could be 0 out of 10 were 2s. It's not going to be this 1/6. If you rolled it 100 times or 1,000 times or 10,000 times, the more you conduct the experiment, or if you're surveying people, the more people that you're surveying, like the more you do the actual experimental or empirical probability experiment, the closer you get to, the theoretical probability. That's all it's saying. So anytime you see statistics and you see, oh, only 100 people were surveyed, and they're making assumptions off of this, like that's not a good survey. You need to or we've only tried this, 10 times, or like cars, if they're trying to, make sure cars are safe. Oh, we only did a test drive once. You don't want those types of things. You want them doing much more for that. All right. The third type of probability is subjective probability, and it results from intuition, educated guesses, and estimates. Classify each statement as an example of classical, empirical, or subjective probability. Explain your reasoning. The probability that you will get an A on your next test is 0.9. This is actually subjective. Okay, it's definitely not going to be theoretical. The reason it's subjective is you are making an estimated guess, an educated guess, sorry. You are making, there we go. And there we go. Educated guess about your next test. Now you might have done really well on all your previous tests, so you're just kind of estimating that, but none of you're not actually running an experiment or running anything like that, so you can't call it empirical. All right, so the probability that a voter, there's an extra A in there, sorry, that a voter chosen at random will be younger than 35 years old is 0.3. This would be empirical or experimental, because they run surveys and statistics on voting and on voters and everything like that. So you've got data to back that up. And then the probability of winning a 1,000 ticket raffle with one ticket is 1 out of 1,000. This would be theoretical. Ooh, I hope that yellow shows up. Theoretical or classical, sorry. Okay. Because you bought one ticket, so there is your one simple outcome out of the 1,000 that you have. Okay, or the 1,000 that were sold. Okie dokie.